Welcome to Ask and Learn.
We want to sketch the curve y is equal to x minus 4 times the cube root of x. Now in this chapter they give us this laundry list of steps we should follow. So we're just going to go one by one through that list. The first thing they suggest that we find is our domain. Now we know x minus 4 is going to be defined for all values of x, as well as the cube root of x. So the domain here will just be all real numbers or negative infinity to infinity. The next thing they suggest we find is our intercepts. So let's go ahead and look for the x-intercepts first. So remember, that's where our function is equal to 0. So 0 is equal to x minus 4 times the cube root of x. So using the zero product property, that tells us either x minus 4 is equal to 0 or the cube root of x is equal to 0. So x is equal to 4 or x is equal to 0. And we don't even need to go find our y-intercept, since when x is equal to 0, that would give us our intercept. So our y-intercept will just be the origin. Next thing we can look for is symmetry. So this isn't one of the functions, or it doesn't have one of the functions known for being periodic. So we can just go ahead and check to see if it's even or odd, see if it's symmetric about the origin or the y-axis. So plugging in negative x, we'll get negative x minus 4 times the cube root of negative x. So since that is an odd degree root, we can factor that negative out and distribute it to negative x minus 4, which would just be x plus 4 times the cube root of x. Now this here does not equal to f of x, nor is it negative f of x. So this tells us we have no symmetry for the function, or at least no symmetry about the y-axis or about the origin. The next thing we want to look for is asymptotes. So in this case, we're not going to have any true asymptotes in the sense of particular values will get really close to anything, but we can at least check the end behavior of this function. So let's look at the limit as x approaches infinity of f of x. So x minus 4 will go to infinity, and the cube root of x is going to go to infinity as well. So the end behavior on the right is going to go to infinity, and now checking the end behavior on the left. Well, negative x minus 4, or x minus 4 is going to go to negative infinity, and the cube root of x is going to also go to negative infinity. And then multiplying those together, we would get an end behavior of infinity. So on each side, our end behavior goes to infinity. Now I'm going to combine the next two steps into one. So I want to find where the function is increasing, decreasing, and any local max or mins we may have. So to do this, we need to know what y prime is. So we can go ahead and do this on another page. So this first step I did here was just rewrite our function to make it so it's in something we can use the power rule to take the derivative of. So we end up with 4/3 x to the 1/3 power minus 4/3 times x to the negative 2/3 power. Now we can go ahead and combine this into just a fraction, and doing that little bit of algebra, we get 3 times x minus 1 over 2 square roots of x. All right, now we can go ahead and set this function equal to 0, so we can find our possible maxes and min. So the only thing that's going to make this equal to 0 is where the denominator, or the numerator, is equal to 0. So x minus 1 is equal to 0, or x is equal to 1. Now, something else we also need to check is where our derivative is undefined, and that's going to be where our denominator is equal to 0. So that would say the square root of x is equal to 0, or x is equal to 0. So since x is equal to 0 is in our domain of our original function, x is equal to 0 will be a critical point. for this. So if it isn't a max or a min, we at least know it's going to have an infinite slope at that point. All right, so now let's go ahead and write down what we found. So we found our first derivative is going to be 4 times x minus 1 over 3x to the 2/3. Now we need to figure out where this function is increasing. So it will be increasing when y prime is strictly larger than 0. So that's going to be the interval 1 to infinity. And we know this function is going to be be decreasing when y prime is strictly less than 0, which is going to be negative infinity to 0, union 0 to 1. Now let's go ahead and put those 2 points we found before and see if we have maxes or mins out of them. So we had x is equal to 0, x is equal to 1. So to the left of x is equal to 1, the function is decreasing. And between 0 and 1, the function is also decreasing. And then after x is equal to 1, the function is increasing. So at x is equal to 0, we're going to have a saddle point. And we know this should have an infinite slope. Now, at x is equal to 1, this is going to be a local minimum. So a minimum by just using the first derivative test. The last step that they said we should do before we actually start graphing is to find concavity and any inflection points. So we need to know what y double prime is equal to. So I'm going to come over here and look for the second derivative. So I'm going to use this form here to take the derivative just because it will make it a little bit easier to do the math. So we're going to end up with 4 over 9 x to the negative 2/3. And then those negatives will cancel out when I take the derivative of x to the negative 2/3. And that would give 8 over 9. Now x to the negative 5/3. And using a little bit of algebra, we can rewrite this to get 4x plus 2 over 9 x to the 5/3. So again, we're going to set the function equal to 0, and that will only occur when x plus 2 is equal to 0 or x is equal to negative 2. And then we need to set our denominator equal to 0 because the function will be undefined there. And that will tell us that x to the 5/3 is equal to 0 or just x is equal to 0. All right, so these are our two possible points of inflection since x is equal to 0 is in our domain. All right, so we have y double prime was equal to 4x plus 2 over 9x to the 5/3. So we want to find where this function was concave up. So remember, concave up is going to be when y double prime is strictly larger than 0. And I solved this beforehand again, just to save a little bit of time. It would be negative infinity to negative 2, union 0 to infinity. And this function is going to be concave down on y double prime strictly less than 0. Or this would be negative 2 to 0. All right. So what we need to do now is go ahead and use those two possible points of inflection, which were 0. Actually, let me go ahead and write negative 2 first, and x is equal to 0. So to the left of x is equal to negative 2, this function should be concave up. And to the right of negative 2, the function should be concave down. And to the right of 0, the function is going to be concave up. So we have that both of these are points of inflection. Now let's go ahead and start graphing. So our intercepts, we have the origin. So that's one of our x-intercepts as well as our y. And then to find our other one is going to be x is equal to 4. So we have our two intercepts there. We have no symmetry. We know the function is going to go to positive infinity for our end behavior on each side. We know at x is equal to 0, we're going to have a saddle point with infinite slope. So I'm just going to go ahead and draw a horizontal line or a vertical line like that, just to remind us that we need infinite slope there. And at x is equal to 1, we're going to have a minimum. So at x is equal to 0, we're also going to have a point of inflection. And at x is equal to -2, we should have a point of inflection as well. All right, so what I'm going to do is start from negative infinity, or as x is approaching negative infinity, and work my way to the right. Now, to the left of x is equal to -2, the function should be concave up. So I'm just going to start at this point here, and it should be concave up, something like this. And after this point, the function needs to be concave down until we hit our next point of inflection, which is our origin. And we know at that point it needs to have a infinite slope, like we do there. And then concavity is going to change on the other side, and it should be concave up. We hit our minimum at x is equal to 1, and we're going to go, try that again. All right. So at x is equal to 1, we have our minimum, and then it's going to start increasing again until, well, just for the rest of it. But we need to make sure we hit our next intercept at x is equal to 4. So not very prettily drawn, but since we're just trying to sketch it, this here gives all the information we really need for this. So some things you could possibly go do to just make it look a little bit nicer is say what the value here for the point of inflection is at x is equal to -2, as well as what our minimum value actually is at x is equal to 1. But I think this is sufficient enough since we just want to sketch the graph.